All right. Well, hello, everyone, and thank you so much for joining us today. Like Han said, this is our kickoff for our series talking confidently about climate change in Indiana and beyond. Really, our goal with these trainings, it's really designed to help educators and professionals really expand their knowledge about why our climate is changing, what it means for us here locally, and what we can do about it. And our goal these next couple of weeks with these sessions is really to give you that plain language information that helps you build confidence in having these conversations, both in your personal lives and mostly your professional lives. And we really hope that it helps you feel empowered to start taking action to address this critical problem. So I join you here today from my home in West Lafayette, Indiana. When we're not dealing with a global pandemic, you can find me on the Purdue University main campus. I'm an operations manager with the Purdue Climate Change Research Center. And one of my primary responsibilities is overseeing the Indiana Climate Change Impacts Assessment, which we'll get into in a little while. My academic training is in the fields of meteorology and climatology. And over the last decade, I've spent the majority of my time on projects like the Impacts Assessment that really try to make climate information more usable to people throughout the Midwest. Okay, so today's presentation, what does climate change mean for Indiana? This is actually one that the Purdue Climate Change Research Center often takes on the road to community meetings and to professional gatherings around the state. And it's really intended to give you that solid overview of global climate change, local impacts, and strategies for individual action, with the bulk of the material focused locally on information related to the impacts assessment. Throughout the presentation, you'll hear me briefly touch on a lot of topics that our speakers in the series are going to really dive deeply into in these remaining 5 sessions. So you'll hear me say this more than once today. If you're not already signed up for those other sessions, go to the website, purdue.edu/climate. You can find the registration on our homepage, and we really hope that you'll continue to join us these next couple of weeks. Now, as I mentioned, one of my primary roles is focusing on the impacts assessment, which really looks at this question: what does climate change mean for Indiana? And in the process of answering this question, I spend a pretty big chunk of my time also trying to increase awareness throughout the state and really increase that dialogue about climate change issues throughout our state. Now, as you can imagine, this can be a bit of a challenge, since a lot of times when people hear the phrase climate change or global warming, what pops into their mind is something like this. All right, some poor polar bear floating away on this melting bit of ice at the far end of the earth, or maybe something like this, some distant time in the future. And unfortunately, this frame of reference that has been given to us for many, many years makes it really difficult for people to see and appreciate climate change as a really local issue throughout the Midwest. And so over the next 40 minutes or so, my goal is to try to take this global topic and give it that local perspective, so that when you hear climate change or when somebody says it, the image that pops into your mind, rather than this beautiful polar bear, is something more like this. Okay, our health and our well-being, our communities, our social and physical structures, our families, our potholes, right? These are the types of things that make up Hoosier life. These are the types of images that describe how climate change will be affecting us and our day-to-day lives. Okay? But before we jump in, we like to start really far zoomed out, just to give us a little bit of perspective. So we'll start here with these 2 illustrations of our world with these 2 colored dots on top. Now on the left, this blue ball is actually representing all of the water found on Earth. So if you took all of it, the oceans, rivers, ice caps, groundwater, in our bodies, in the air, you crammed it all together, the size of that ball of water would be right there on the left, that blue ball, that little blue marble. So it's a pretty thin layer when we look at it like this. Now on the right-hand side, this pink ball, that's actually showing us a representation of our atmosphere. So if you took all of the air from the surface of the Earth up to the top of the sky and all around the world, crammed it together and stuck it in a balloon down at sea level pressure, that pink ball is the size of that balloon. So also a very thin and fragile layer. And we're all breathing and driving and flying, well, we used to be flying and running our factories inside of this pink balloon. Okay, all 7 billion of us here on planet Earth. Now, when we start thinking about the atmosphere in this way, we can really start to understand that we can have an impact on that atmosphere. And in fact, we have. Okay, all of that flying and driving and energy generation and factory operating, that's converted billions of tons of fossil fuels like coal and oil into carbon dioxide. And as we put that carbon dioxide into the atmosphere, the concentration of that gas has risen dramatically. So since the start of the Industrial Revolution, we've increased the concentration of carbon dioxide in our little pink balloon by about 40%. Now what you're looking at here on the screen, in red, that red line is showing us the concentration of carbon dioxide in our atmosphere over about the last 130 years. And in white, we're looking at the year-to-year change in global temperature. And you can see just how closely these two track one another. As we get more carbon dioxide, our temperature rises. Okay, so how does this work? Well, carbon dioxide is what we call a heat-trapping gas, or oftentimes you'll hear it talked about as a greenhouse gas. Those greenhouse gases are molecules like carbon dioxide and methane and others. They have this unique ability to let light from the sun pass right through the atmosphere and warm up the surface of the Earth. But then those gases will block the heat that's radiating off the Earth and trying to escape to outer space. Okay, so you can think of it like a giant clear blanket wrapped around the Earth. And as we burn coal and oil and natural gas, all the things we use to power our modern lifestyle, it's like adding another blanket when we're already perfectly warm. Now, this concept of heat trapping gases is not, and how it warms the world, it's not new. Scientists discovered this connection between burning fossil fuels and warming temperatures way back in the 1850s. Now, let's look at this another way. Here, for each year from the late 1880s to 2014, we're looking at how much Earth's average temperature was warmer or colder than a long-term average. And you can see that temperatures are on a rapid upward trajectory. In fact, 19 of the 20 warmest years that we've recorded have all been since 2001. Now, when this graphic was developed, it's a little bit old. It was developed in 2014, and that year had just been named the hottest year on record. But that was short-lived because both 2015 and 2016 were the warmest years on record. That trend has continued on, and 2019, last year, actually came in at the second warmest with 1.71 degrees Fahrenheit above the long-term average. Okay, it was the 43rd consecutive year of above average global temperatures. Now, if you're wondering about this year, the National Oceanic and Atmospheric Administration just a little over a month ago said once again, 2020 is on track to be among those warmest years on record. So this is a long-term pattern of warming that is continuing on and on. Now, a few degrees of change might sound small at first, but it's not. You have to remember, we're talking about the climate, not the weather. The weather is a snapshot of what's happening in a specific place, at a specific time, And it can swing wildly from season to season or even day to day. It just depends on where you're at in the world. Our climate, on the other hand, is that long-term average of weather conditions over many decades. Now, I like to think about our average climate, our average temperature, like our body, okay? Because it's very, very stable. When you look at Earth's temperature averaged over the course of the year, it only fluctuates a few tenths of a degree from year to year. So when we start talking about a full degree or 2 or 3 of warming in that long-term average, that's important. That translates to some pretty dramatic shifts in our local weather patterns. Now, this problem, it goes beyond changing temperatures alone. As the Earth warms, we are seeing alarming trends in key environmental indicators worldwide. So I'll give you just one example here of Arctic sea ice, which has been warming and melting so quickly that our university scientists are telling us at this current pace, we could start seeing consistent areas in the Arctic with ice-free summers as early as 2030. Now, these changes at the end of the Earth, I realize they seem distant, but it's absolutely critical when we're thinking about this to understand that our climate is an interconnected system. So conditions in the Arctic, they control the large-scale wind patterns across the whole entire northern hemisphere. That, in turn, determines the path and the intensity of the local storm systems that come right here through the Midwest. I'm sure that many people on this call remember how earlier this year, yet again, that phrase, polar vortex, it was part of our everyday vocabulary. That was a perfect illustration of the interconnectedness of that global climate system we live in. Now, we're not only seeing shifts in key indicators in faraway places. Our scientists are measuring and monitoring changing conditions right here at home in Indiana and throughout the Midwest. Okay, we can see it in our temperature record. That shows us that Indiana's climate has warmed 1.3 degrees over the last 125 years. Remember, we're talking about the climate, not the weather. That's a pretty big deal. With that 1.3 degrees of warming, that's translated to shifts in our frost-free season. Okay, so we see about 2 to 3 weeks more frost-free period now than we did 50 years ago. On average, we're seeing fewer cold days. They're not gone, okay? Winter's not gone. This is a northern climate, but they're different than they used to be. Our overnight temperatures are warming at about almost twice the pace of our average temperatures. So we can see this change in our temperature record right here in Indiana. Similarly for states all around the Midwest, the further north you go, the more warming they're seeing. So Minnesota, Wisconsin, Michigan, they're warming at an even greater rate of change. So we see it in our temperature record, we see it in our rainfall record. Okay, our rainfall record here in Indiana shows us that nowadays we have about 6.5 more inches of rainfall annually than we did 125 years ago. Here on the screen, we're looking at different regions of the state. All of the regions are showing an increase in rainfall, but the southern part of the state is showing the most increase. We have places in southern Indiana that see more than 8 inches of annual rainfall compared to what they did over a century ago. And again, similar trends throughout the whole Midwest. Indiana takes the lead for the most rapid amount of change, but everywhere throughout the Midwest, they're seeing that similar upward trend in rainfall. Now, not only are we seeing more total rain, we were just talking about annual rainfall, but the nature of storms themselves has shifted. So heavy rains are more intense. They're happening more often. When we look across the Midwest as a whole, those heaviest storms have about 42% more water in them than they did 50 years ago. So those biggest storms are getting bigger. We have research here for Indiana weather stations that show us an increasing number of 2-inch events, 3-inch events, 4-inch events. So if it feels to you like there is more rainfall, more of these heavy storms, your perceptions match the data. And as we have more total rainfall, as we have an increase in heavy downpours, that's translating to an increase in stream flows. That's giving us a greater risk of flooding. In this pattern, I'm showing you Indiana, but this pattern, again, it looks similar across the majority of the Midwest. So this is not just an issue for faraway places at distant points in the future. We have multiple lines of evidence that show us our climate is already changing right here in Indiana and in surrounding states, and it is affecting our families and our businesses and our communities. Now, given the changes we've already measured, it's a very valid question to ask, should we expect this to continue? And if so, what are the impacts that we can expect here at home as climate patterns shift worldwide? Now, these are the types of questions that our faculty at the Purdue Climate Change Research Center have been asking for quite some time. So the PCCRC, as we like to call it, we are a faculty-led center at Purdue working to really understand the impacts of climate change and to develop novel solutions that help people reduce their emissions and plan for a better future. We've been around for a little while. We were established in 2004, and we're pretty big. We have over 90 affiliated faculty on campus working across 26 departments, all that work on some aspect of climate change. In keeping with Purdue University's land grant mission, our faculty are involved in education, they're involved in research, they're involved in outreach, all three. And as a center, we really strive to be a trusted source of science-based information for decision makers here in our state and beyond our state. Now, this isn't the first time that the PCCRC has helped answer this question, what does climate change mean for Indiana? Back a little over a decade ago, our former U.S. Senator, the late Senator Lugar, reached out to Purdue. He said, I need to know about climate change. Can you help me out? I said, yeah, of course we can. Well, great. I'll be back in touch in 3 weeks. Oh, boy. So in a pretty quick turnaround, we were able to pull together from our experts across campus and quickly write this report that you see here on the screen, the impacts of climate change for the state of Indiana. Now, this has been living on our website. It's been used by a variety of groups in a variety of ways, but it was starting to reach the point where we needed an update. And so a couple of years ago, we decided it was time to try to work on this, but we wanted it to be more comprehensive, and really, this is key, to include a much broader group of experts from across the state. And so now, with nearly 100 collaborators on board, the Purdue Climate Change Research Center is leading a statewide voluntary effort to assess what these changing climate conditions mean for our state and our local interests. And we're also working to elevate those discussions around climate change in our state. And together, we call this effort the Indiana Climate Change Impacts Assessment, or sometimes you'll hear it INCCIA, since we love our acronyms. Now, one of the primary outcomes from this work is a series of sector-based, plain language reports on the topics you can see here on the screen. We are releasing these topics individually, starting with our climate report back in March of 2018, and right now we have 8 of those available. I encourage you to please go to our website. It's indianaclimate.org. There you'll be redirected to a purdue.edu website where you can find all of these reports, plus a whole lot of other information about our changing climate. We don't have enough time here today to go through all of the key findings from that report, but I will share just a few brief takeaways. And this short summary, it's just barely going to scratch the surface. So please be sure to visit indianaclimate.org. You'll find the reports, you'll find my contact information. I invite you to reach out to me personally if you have questions. I am here as a resource for you. All right, so let's just go ahead and jump right in. Let's not waste any more time. The first big takeaway from our impacts assessment, and really I'm guessing this isn't going to be a surprise to anyone, our scientists here in Indiana are expecting that our temperatures are going to be getting warmer, okay, a lot warmer. So what we're looking at here on the screen, we are showing Indiana's statewide average temperature because it's a pretty helpful indicator of the general trend in our overall climate. This orange line is showing us how much above or below that long-term average each year has been since 1900. And that black line is showing us that 1.3 degrees of warming that we talked about earlier. Now, as we move to the right half of this graphic, future temperatures are being projected. For the Indiana assessment, we used 10 different climate models to look at future changes, which gives us a range of outcomes and some pretty clear patterns that emerge. Now, this red area is showing us the temperature projections if we were to pretty much do nothing or to do very little to change that emissions of heat-trapping gases around our world. The green area, by contrast, is showing the projected temperatures for our state if we were to act pretty quickly and pretty aggressively, globally as a world, to reduce those heat-trapping gas emissions. So based on the best available computer simulations that we have, our scientists right here in Indiana have concluded that our state's annual average temperature is expected to increase by 5 to 6 degrees by the middle of this century and up to 10 degrees in a worst-case scenario by the end of this century. And really that range just depends on how much we slow or don't slow that emissions of heat-trapping gases. This is a tremendous amount of warming. Now, there are 3 important takeaway messages that I want to point out before we move on from this graphic. The first one, you will notice that we expect the warming trend that we've detected over the last century not just to continue, but to accelerate. Now, this is because that primary driving force of these changes, those heat-trapping gases, those are long-lived in our atmosphere, and their effect intensifies as they accumulate. The second important message that I want to point out is that based on the amount of heat-trapping gas already in the atmosphere, if we were to stop emitting today, we are still going to see some change. So if you focus in on that warming trend in these coming decades, you'll see that those 2 colored paths are pretty much right on top of each other. And so what that is telling us is that communities need to acknowledge this fixed level of change, and they need to start planning for it. And the third critical message that I want to point out is that we have a choice in our future, but we have to act pretty quickly to reduce emissions if we want to avoid the most severe impacts. It's after about that middle of the century area time point when there are really significant differences in that projected future. Okay, so it's important to realize that while we're often talking about average temperature when we're talking about climate change, as you might assume, that's not the only thing that's going to change. You can think of average temperature like a loose string on a sweater. You give that thing a tug and a whole lot more is going to unravel. So when we start seeing changes in that stable, long-term average temperature, that means we're also going to see shifts in our temperature extremes, shifts in the timing of our seasons. We're going to see changes in the water cycle too. Remember, this is an interconnected system. So let's look at just one example on the heat extreme side to help illustrate the magnitude of changes that are underway. So here we're looking at on the screen the average number of days each year for Tippecanoe County where temperatures reach above 90 degrees. We have these data for all locations across the state. I just picked where I'm sitting because that's what, speaker's preference. So we're looking at those average number of days when we hit 90 degrees. And if we look in the past, that happens about 20 times here in our county. Now, this is an average. Some years we'll see a lot more. Some years we'll see a lot less. When we average it out, that gives us this benchmark, this baseline that we come to expect. Okay, this is what we plan around. This is how we set our expectation of our climate. So it's not unusual. It happens 20 times a year, but we all know just how uncomfortable a 90-degree day can be. We all know how dangerous a 90-degree day can be. If you don't have air conditioning or if you work outside, 90-degree day is pretty intense. It's when you hit above that 90-degree mark that air quality starts to decline. Okay, if you're somebody with asthma or pre-existing condition, that can be dangerous or life-threatening. When you hit above that 90-degree mark, water demand really changes. The amount of water we need for people, plants, and animals all goes up. So these are real impacts on real people right here in our community. And it doesn't take some unspeakable temperature to get there. Even reaching a 90-degree day will do it. So anyway, in the past, we've seen this about, we can expect it about 20 times a year. If we move forward to the middle of the century, and we're looking at that 5 to 6 degrees of warming in our average temperature, that actually translates to seeing about 57 to 70 days each year with temperatures above 90. Let that sink in for a moment. That is alarming. That is scary. It makes me feel scared. I really wish that wasn't the news I had to share. We are talking about changes in these extremes that will affect all of us. Now, if we look at the flip side, while we'll be seeing an increase in heat events, we're also expecting to see a decrease in our cold events, right? Fewer days dropping below zero. A pretty significant warming in our lowest temperature of the year. Here, what I'm showing us on the screen is that average lowest temperature. On the left side of those bars, that's in the past. On the right side, it's projected for the future. That range is depending on that medium or high emissions scenario. Again, these are averages. Some years it'll be much colder, some years not so cold. You average it out to get that baseline, to see that expectation. Now, when I look at this, one of the big risks with these warming winters that comes to mind are the unintended consequences that we are facing in terms of insect pests and invasive species. For a lot of these pests and plants, their ranges are determined by the types of temperatures they can tolerate. And right now, it's that coldest night of the year that keeps a lot of those species out of our area, or at least kills them back. Some of these pests might harm human health. Some might be harmful to agricultural crops or even to forests. Anyone who's maybe had an ash tree in their yard until recently can really truly appreciate the impact that even just one species can have on an ecosystem. Okay. Now, if we're thinking about, remember I said when we change that average temperature, a lot of other temperature components change. Changes in our extremes, changes in our seasons. Looking at shifting seasons, let's look at just one example, and that has to do with the length and timing of our frost-free season. So that's the consecutive period of time between that last spring freeze and that first fall freeze. So when you warm up and you stay above freezing, that's the period of time we're talking about here. What our scientists are telling us is that here in Indiana, we can expect to see about a month longer frost-free period throughout the state. For Tippecanoe County specifically, that ranges from 26 to 33 days. So spring starting a little bit earlier, fall coming a little bit later. Remember, these are averages. Each year is not going to be exactly like this, but these are the long-term patterns that will be emerging. Now, There are a lot of ways that seasonal shifts can affect natural and human systems, but let's talk about just one example that I think a lot of us can relate to, including my household, and that's seasonal allergies. Okay, so when we're talking about allergy season, we're pretty much talking about the frost-free season. It really ramps up after we have those last freezes in the spring, and it doesn't end until you get a couple of those hard freezes in the fall. So, if we have a longer growing season, we just have a longer period of the year when we are exposed to those allergens. Now, we have to remember too, warmer conditions and higher CO2 levels in the atmosphere, that also promotes accelerated plant growth. It increases the overall amount of pollen in the air. There's been research that shows not only is there more pollen, but the allergenicity of the pollen is more intense. So if you don't have allergies, a longer, more intense pollen season might not sound very alarming, but if you do, or if somebody in your family does, you know how much outdoor allergies can affect a person's quality of life and can affect their overall well-being. All right, so like I said, temperatures in Indiana are going to continue to get warmer. We're going to see shifts in our hot and cold extremes. We're going to see shifts in our timing of our seasons. But temperatures aren't the only thing that's going to change. We will also be seeing changes in our precipitation. And so that's why another key takeaway from our reports is that water is going to be a problem. So if we're looking at our annual rainfall, by the middle of the century, we are expecting to see about a 6 to 8% increase. Now, I'm a Midwesterner, you're Midwesterners. That might not sound like very much. We are constantly dealing with a lot of water. But where it really gets tricky is when we look at how this is distributed throughout the year. That's when a different picture emerges, one that's pretty alarming. What we see when we look at this change in rainfall by season, we see significant increases in the winter and spring, which is a time of the year when we are already prone to flooding and we just don't need the water. And we're starting, our models are showing us we can expect some modest declines, we'll call them, in the summer and fall. Okay, it's pretty tricky to pinpoint those changes in the summer or fall. We have a lot of confidence in that winter and spring, a little less confidence in the summer and fall. But every indication is showing us that we'll have some modest declines. Okay, well, that's a time of the year when we actually need the water. We need it for our drinking supplies, our crops, our wildlife. And when we pair those modest declines with the added heat we were talking about, this is going to lead to water stress, possibly water shortages. So if we are going to be more resilient in the face of a changing climate, we're going to need to better manage for times of too much water and times of too little water, and maybe even in the same season or in the same year. So when we're thinking about these overall changes in temperature and in precipitation, we have to remember we have built our society around a certain set of climate expectations. And when we start tinkering with one variable or another, when we pull the string on that sweater, we will have cascading, far-reaching impacts. And that's another takeaway message that I want to point out from our assessment. We will see cascading, far-reaching impacts that touch all aspects of our lives. Now, we have a lot of examples of impact pathways throughout our various reports, but in the interest of time, let me show you just 3, okay? So when we are drastically increasing our spring rainfall, that is saturating our soil at a time of the year when crops aren't yet active. This, in turn, is going to drive up the volume of subsurface water that's being tile drained from our crop fields. In central Indiana, what we're looking at here on the screen, you can look for northern and southern as well. In central Indiana, that translates to about a 29 to 47% increase in the amount of water coming out of those drain pipes in the spring. When that happens, that's going to require us to upgrade our drainage infrastructure so we can accommodate those flows. This is going to have implications for downstream water quality as nutrients are pulled from those fields and deposited into our waterways. This is going to create flood control issues, especially if locations downstream from us are also saturated and they can't take on more water. And this is all in addition to the problems directly facing farmers with delayed field work and with soil erosion issues. Okay, cascading, far-reaching impacts. Now, it's not just a problem for rural areas or for the environment. Okay, urban areas are also going to face significant challenges. Whether we're talking about our ability to manage traditional stormwater and sewer drainage systems during these heavy rainfall events, or if we're trying to deal with those negative impacts to our green infrastructure from heat and from water stress. So urban green infrastructure, those are the forests, the green roofs, the community gardens, the native plantings that provide us with tremendous economic, environmental, and health benefits. Right? They're very valuable to our well-being. And all indications are telling us we are going to depend more on ecosystem services, and that reliance is going to be amplified as our climate changes. But the kicker is that it's also going to become more difficult to manage the functionality of these systems in a changing climate. Okay, cascading, far-reaching impacts. Okay, one last one before we start to wrap up. And this one comes from our Tourism and Recreation Report. And it says that climate change is going to affect the timing, the enjoyment, and the safety of outdoor activities. And that's going to affect the visitors as well as the businesses and communities that are serving the tourism industry. So when we have reduced water quality, like we were just talking about in the last two slides, that's going to affect our water recreation, our fishing, our swimming. When we have increased heat, a lot of our land-based activities and sporting events are at risk as heat exhaustion concerns start to rise. We didn't talk about crop production today. We have a whole report on that. And what it tells us is that we can expect lost yield potential and reduced food quality. That's going to affect our U-pick farming. That's going to affect our agritourism. So there are seemingly endless impact pathways that lead us back to the negative effects on the timing, the enjoyment, and the safety of outdoor recreation and tourism right here in Indiana. This is going to affect our quality of life. This is going to affect our physical and mental health too. Whew. Okay, I have given you a ton of information. I have given you a lot to think about, and we've barely even scratched the surface. Let me give you the 45-second recap. So our historical observations show us that Indiana is getting wetter and it's getting warmer, and the best available science that we have is telling us that we can expect these trends to continue and intensify. In the coming decades, we're going to face growing challenges related to extreme heat and to heavy rainfall. And in order to effectively manage our climate risks and our water risks, we're going to have to account for these seasonal shifts in addition to the annual trends. And I can't say this enough. You're going to get sick of hearing this. The impacts of climate change will touch all aspects of our lives and result in serious local consequences. And finally, let's not forget where we end up depends on the choices we make. It's also important that we recognize, for the most part, climate change is going to be hitting us where we are already vulnerable to naturally occurring weather and climate extremes. Climate change it's like it's loading the dice. Okay, it's making the problems we already face even more risky and even more likely. And thinking about vulnerability, thinking about that word vulnerability, we need to recognize that the impacts of climate change disproportionately affect Hoosiers that are already the most at risk. So children, the elderly, Black and minority residents, people with chronic health conditions, low-income families, financially insecure families. These are the folks who stand to lose the most as environmental conditions deteriorate. So the bottom line is that the struggles we know today, they are not going away. They're going to continue and they're going to intensify. And this makes building more resilient families and communities a top priority. Now, that is not to say it's going to be a simple task. And especially since we are adjusting to life during a worldwide crisis. But preparing for climate change is something we cannot continue to ignore. This virus has given us a very harsh lesson in exponential math and in multiplier effects. It has demonstrated how deeply our health and our economies are affected when we have global scale catastrophes. It's showing us how interconnected we really truly are. The reality of climate change is that abrupt shifts are very much a possibility, and there are tipping points that once they are crossed, they cannot be undone. That will have devastating consequences. Now, there are a lot of lessons that we can learn about preparedness and response that come out of this coronavirus pandemic and that apply to climate change. And we have to think about it. As we start the process of rebuilding our economy, we're actually given a pretty amazing opportunity to rebuild it in a more sustainable way, if we choose to do so. So I have this question up here on the screen. Is this the perfect time or the worst time to be thinking about climate change? And if you ask me, I'm sure you already know my answer. This is the perfect time. And that's because it is not too late for us to bend the climate change curve. It's not too late to shift course, to slow or to stop that large-scale warming. It is not too late for us to build more sustainable communities. There are many reasons to have hope, but this stuff takes time, so we cannot put it off. Now, lasting solutions to climate change, that's going to require action on a global scale. That is going to require participation and, more importantly, leadership by our most influential governments and by our businesses. But there are many ways that we as individuals can help pave the way for bigger changes to come. One important action is something that each and every one of you did here today, and that is to learn the basics. Okay? This is something we're going to continue doing in our upcoming training sessions as well. Here in this talk, we just barely grazed the surface on the greenhouse effect and some of the global drivers of change. Join us on Thursday, this Thursday, and we're really going to dig into that because it is absolutely critical that we learn the basics. We must understand climate change is real. We are the cause. Experts agree. The impacts are severe, but that there is hope. Okay? It's also helpful if we know our own personal impact, right? And then we try to make sensible changes where we can. The reality is that you and I, as individuals, don't control the majority of our carbon footprint, but we control some of it. And if we can make changes, if we can evaluate our transportation, our food waste, our energy efficiency, and change what we can, that is being part of the solution. One very impactful way, but often overlooked action that you and I can take is simply to talk about climate change with our families and our friends and our coworkers, okay? When we talk about change, this helps increase awareness. And there's actually research out there that shows people who are talking about climate change have heightened concern about the issues and tend to have more support for action. There's also research out there that shows, despite that fact, less than a third of Hoosiers are actually having these critical conversations. So we have a lot of ground we can cover here. And that's why we have an entire training on June 23rd focused on strategies for navigating these tough conversations. And that's why our primary goal with this entire series is to increase your confidence in talking about climate change. Finally, and I would say this is probably the most important thing that we can do as individuals, and that is to engage in active citizenship and engage in climate leadership. Your vote at every level of government absolutely matters. Your voice matters. Supporting climate-friendly policies and investments in your business, in your school, your place of worship, your social clubs, that can lead to meaningful change. Finding ways to integrate climate leadership into your professional work, that is essential. And that's why we're going to take a deep dive into that specific topic in our final training on June 25th. Here we've just been talking about individual actions. Join us on June 25th. We're really going to get into that so what? What do we do about this on a larger scale? So I ask each of you, when we leave here today, I'm inviting you to please join me in continuing to build awareness about our climate change, our changing climate. Join me in helping others understand what it means for us here in the Midwest. Find ways to help communities and families and other professionals be more ready for the changes that are underway. In addition to joining our remaining sessions, I encourage you to please check out indianaclimate.org. On that site, you're going to find at the top a tab that says Resources. In it, you'll find where you can sign up for our newsletter. You can download talking points. You can find presentation templates and so much more. You can also go find us on social media at Purdue CCRC on several of the major platforms, or simply reach out to me. I'm going to have our contact information up here momentarily. All right, so thank you so much for your time and for your attention and for joining us on this somewhat rainy day. Please join us on Thursday as Hans Schmitz and Austin Pearson will talk about Back to Basics, the science behind climate change. So really digging into some of those details on the science there, what's going on with the greenhouse effect. How do we know people are the cause of this? Okay, a lot of those fundamental questions that'll help you be more confident in talking about climate change. And finally, I'll leave this up here on the screen for a minute. Take a screenshot of this if you're able. This is our digital business card, contact information for all of the co-hosts that are part of this series. And if you need help finding information about climate and climate change at Purdue, these are the folks you'll want to reach out to. So with that, thank you so much. Looks like we have about 7 minutes for questions. And so I'm going to go ahead and pause this presentation and turn my camera back on and turn it over to Hans to help us with some Q&A.
Okay, first question. Melissa, would you be willing to share this slide deck?
Yes. Just send me an email and I am happy to share this with you. We also spend a lot of time going around to communities and giving similar talks like this. Obviously, that's a little bit of a challenge right now to physically be there. But we do remote ones as well, and we can, focus in on other topics that are throughout the impacts assessment, and, just send me an email. I'm your first point of contact to getting that information.
All right. Next question.
I think that's a great presentation. There's a couple of things that I find difficult typically to explain to people, and it's often in my reading, it seems to be related to how well we have in our, if you will, our gut understanding, which is usually a very linear, simplified way of looking at things. The ideas of things like exponential gain and also statistical distributions. So I was wondering if there's enough data that the actual statistical distributions of the temperatures in Indiana could be put in a plot that demonstrates the shape of that plot. Do you know what I mean? So that maybe it's a Gaussian, the way you've drawn a Gaussian curve, which would mean, a random distribution, presumably. But also I'm just thinking that if you could do that, then you could take a swath off the edge and say, here's the 90-degree days, and here's what that distribution looks like at 2050, and look at the 90-degree days. You know what I mean?
I think I know what you mean. I know that our applied climate scientists and our the folks who work on projecting climate change, they have a lot of different ways to slice and dice the data. I think Beth will get into some of that next week when she talks about the data that are available historically. Hans, Jeff, Austin, Beth, any of you want to chime in?
Basically, people don't understand statistics. You know what I mean? They've not taken their basic statistics course in their advanced math.
Scott, and for some reason I'm blanking on his last name right now, which is crazy, but down at IU, professor who works on, what's that?
Robeson?
Thank you. Has done some of these analyses and posted some of them on Twitter. So I will, if I can find those, I'll put them in the chat of this or a future one of these classes.
The same thing is comments kind of go for this nonlinear increasing warming because of the integrated effect, which is very much like this. What you get, exponential growth, you get that when you do investments and you get consistent returns that are reinvested. People think they know about that, but most people don't really have the concept. And it's like those two mathematical concepts are pretty critical to climate change, and yet people dismiss it in their gut because they just think of things as changing, and any change is linear.
It's a good point, Larry. We've got a bunch of other questions in the comments that we should try to get to right now, but you certainly make a good point.
Okay, so I know William's on tap to ask a verbal question, but before we get to him, let's get one more out of the chat. Leslie says it's not too late to shift course, but how close are we to tipping points?
That's a good question. I think one of our biggest challenges is that we don't know. We just don't know what the sensitivity of these tipping points will be. We have a general idea of what they are, at least some of them. We don't necessarily understand all of the complexities of what will trigger it and whether or not once it's triggered it is reversible. Our indications say that they won't be, at least not on our lifetime scale. So no, I can't tell you that.
Okay. Now we'll go to William. You're unmuted. Did you have a question?
I'm not sure whether I'm the William or it's someone else who's a William.
You're the one, sir.
I'm the one. Okay. I'm in Indianapolis, and I have been following for many years, as I guess we all have, the political difficulties in getting major industries to reduce their generation of greenhouse gases. Here we have Indianapolis Power and Light that burns coal to generate electricity. I was sitting at a railroad crossing a few weeks ago and watched a train go by that was loaded with coal in its 108 coal cars, all headed for Indianapolis Power and Light. Now, there's been a major effort trying to stop the pollution by creating legislation that would reduce these emission of gases, and yet they seem to continue to the point where this 108 coal cars in one day headed for one power company is a pretty dramatic example of the amount of pollution that's being caused. And I'm wondering, is there enough of an effort being made to get companies to reduce their creation of carbon monoxide in particular, but also other greenhouse gases? What can be done? What is being done?
Well, I think since you're still seeing coal being used pretty heavily, particularly in some regions, that no, enough isn't being done yet. But I think that transition is happening. We're using a lot less coal than we used to. Granted, here in the U.S., a lot of that burden is being shifted to natural gas, which has its own set of problems and challenges. But it's, if we're looking at carbon dioxide loading, it's better alternative than it is for coal. I think there are a lot of different things happening by a lot of different groups to try to get change to happen, some of it with shareholders, some of it with individuals, some of it just the conscience of the CEOs. But really, we need to have large-scale political guidance. We need to have those folks who are setting our fuel sources and standards and costs and all of that be the ones to help implement that shift if we want to speed it up.
It seems as though we need some sort of a push that we have not found in the past in order to get meaningful change.
That's right. It's certainly a work in progress. And, you know, there's very little that you and I can do. I don't get to pick what energy source is, you know, being used at my power plant when I flip on the light switch and I move into this community. But, you know, our personal options are limited. So, yeah, we need larger scale change.
Thank you.
Jeff's going to chime in.
I'm going to jump in for just a minute there. I mean, the good news on that front is that, first of all, coal has become more expensive than its alternatives, including renewables these days. And the prices of renewables are dropping so fast that they're now, throughout most of the world, and including Indiana, the cheapest new power sources that we can bring online. And so there is an issue that they're variable. And so things like battery storage are useful in terms of offsetting that, and that more grid interconnections can help send power at any given second from where it is most abundant to where it is needed the most when we have variable power sources like those. But they are now the cheapest by far, and so power companies should be installing, you know, essentially exponential amounts of that across the landscape, and coal plants should be closing very rapidly in the near future. Based on economics alone, let alone the environmental impacts. So I think we're poised to go in a very good direction very quickly, as long as people, citizens, make it clear that we don't want any policies propping up the old and more polluting generators of the past.
All right, so this webinar is going to last about an hour, so we'll take a couple more questions from the chat, and then we are going to save the chat. And if you join future sessions, we're going to load those questions into future sessions so that everybody feels like they can go on a relatively decent time and all the questions still get answered. So take about two more here. One is, do we have a release date for the water report?
No, we do not. But stay tuned, and the best way to stay informed of when we have new information coming out is to sign up for our newsletter at indianaclimate.org. Across the top, you'll see a tab called Newsletters, and you can go ahead and add yourself to the list. It's just once a month, sometimes every other month, and they're short because I have to write them. So that's your best way to keep informed when we're getting ready to release a new report.
Okay. As a young climate scientist, this individual cannot ignore the clear connection between climate change and capitalism. Most people are ready to talk about climate, but are not really ready to talk about capitalism's role. How can we go about slowly introducing this idea to people?
Absolutely. So when we look at those individual tips that we shared there at the end, tip number 2 really starts to get at that, right? We need to be evaluating what we're consuming, whether that's stuff or food or oil or whatever it might be. And so I agree with you. We can't ignore capitalism as, you know, a driver there. There's a lot of things we can't ignore. I mean, very relevant this week, right? In the last couple of weeks, we can't ignore social justice. We can't ignore so many of these issues that intersect with climate change. So we need to keep talking about it. Change what we can.
Okay. So I think that's a good place to go ahead and wrap for now. I did want to make sure that if there were any timely questions related specifically to this, we would address those. There was one about PGP certificates available for this webinar, and I'm unaware what a PGP certificate is, so I'm assuming that they're not available.
If there's something somebody needs as certification or verification that they attended this event or any upcoming events, just send me an email and we can try to help you out.